Hello and welcome to Algebra 2, Chapter 7.4, and today we're going to be talking about inverse functions. And so, first thing we need to talk about is, well, how do you find an inverse function? Or what is an inverse function? And an inverse function is a function that maps an output value back to its input value. So if you had a list of x's and y's, and let's say that 1 mapped to 3 and 2 mapped to 5, and 3 mapped to 7. So your x's are your inputs, your y's are your outputs. So your inverse of that would be we take the outputs from the original one and map them back to the inputs. So the basic thing that is happening here is your x and your y are trading places. So that is what's happening. X and y are trading places. And so if you graphed this, it will reflect over the line y equals x, which if you remember the line y equals x, it's about 45 degrees there. It's up 1 over 1 is your slope. And so if we started with the point 1, 3, so let's say 1, 3 is there, then it reflects to the point 3, 1, so it's reflecting over that line. So if you're given a function and you want its inverse, what you're going to do is you're going to switch the x and the y. So this becomes x equals negative 3y plus 6. And in all honesty, that is it. That is the inverse. But what we're going to do to be a little more formal about it is we're then going to solve this equation for y. So subtract 6. X minus 6 equals negative 3y. Divide by negative 3, and I'm going to go ahead and flip it around. Y equals negative 1/3 x plus 2. So that is the inverse function written in slope-intercept form. Okay. So to check that a function is an inverse function, what you can do is you can do your composition functions, f of g of x and g of f of x, and they should both be x. And so if that is true, then those functions are inverses of each other. So this is used to either check that something is an inverse or to check that you've done your math correctly when finding the inverse. And we do denote the inverse of a function as f to the negative first power. And so that is read as f inverse. So we're going to verify that these are inverses of each other. And so what we need to do, so we have f of x and we have f inverse of x, is we need to do f of f inverse of x, that composition, and we need to do f inverse of f of x. So if we remember composition functions, we should insert the middle one here first. We're going to do f of negative 1/3 x plus 2. And so we're going to input that then into f of x. So this is going to be negative 3 times negative 1/3 x plus 2 plus 6. Distribute the negative 3, and we're going to get x minus 6 plus 6, and that is x. So you're just going through the steps to verify, then you should get x as an answer. If you don't get x as an answer, then something is wrong someplace. So f inverse of negative 3x plus 6, and then I'm going to evaluate our f inverse. So this is negative 1/3 times negative 3x plus 6 plus 2. So this becomes x minus 2, it's about to write 6, but multiplied by 1/3. So x minus 2 plus 2, which is x. So that, you have to show all your work here, but this work and these answers of both being x verifies that those two functions are inverses of each other. So find the inverse and then verify that it is the inverse. Okay, so remember, finding the inverse, you're just going to switch your x and your y. So this becomes x equals 1/3 y minus 1. And then you're going to solve it for y, though, so we'll add 1. So So we get x plus 1 equals 1/3 y, and we multiply the entire thing by 3. So I'm going to switch it around, y equals 3x plus 3. So there's my answer. And then to verify, so let's call this first one here f of x, and let's call the second one g of x, just so we know the difference. We're going to do f of g of x and g of f of x. Or you could have called the second one f inverse. Okay, whatever you call it, just something so you know which one you're talking about. So this is going to be f of 3x plus 3. We're going to put that back into our first function, so we're going to get 1/3 times 3x plus 3 minus 1. So this is x plus 1 minus 1, which is x, so it works for that. And then we're going to do g of 1/3 x minus 1, which is going to be 3 times 1/3 x minus 1 plus 3. So this is x minus 3 plus 3, which is x. So then that verifies that this up here is my inverse function. Alright, so here we have a model for somebody's pay for a week. We have S equals 1050 H plus 50, where S is the total salary in dollars and H is the number of hours they worked. So they're getting $10.50 an hour plus this $50 in salary for the week. And we want to find the inverse function of the model. And so there's something a little different. When you're finding the inverse for the model, you do not switch your x and your y, or in this case your s and your h. Alright, so what we're going to do is just solve for h. So if you take the original problem that they gave us, can you get h by itself? So we're going to start by subtracting 50. And so we have s minus 50 equals 1050h, and then divide by 1050. So h equals s minus 50 divided by 1050. So there is the inverse. So if it asks you to find the inverse of a model, you are just solving it for another variable. Alright, so then our second question is, if a person's salary is $5.33, how many hours did they work? So then we can really nicely here put in $5.33, and then I'm just going to use the calculator. $5.33 minus 50 divided by 1050, and we get exactly 46, and that would be hours. Alright, so why don't you go ahead and pause the video and make sure that you can work out this one. Alright, for the inverse I get m equals t minus 29.95 all over 0.05, and for the total number of minutes, substituting in 54:15, I get 484 minutes. Okay, so once again we're back to find the inverse. Now, if it's written with f of x, remember that f of x is just y. So this is y equals x to the fifth. So if I switch those, it's going to be x equals y to the fifth. And then if you're going to solve for y, how is it that you get rid of to the fifth power? You take the fifth root of both sides. Because remember, a fifth root and a fifth power are going to cancel. Y equals the fifth root of x. That is an x. Alright, so one more time here. Remember, f of x is just y, so this is y equals. So when you switch them, x equals y to the fourth power, and then if you want to get y by itself, you're going to do the fourth root to both sides, so then y equals the fourth root of x. So how do you know if the inverse is a function? Because that could be really important. How do you know the inverse is a function? So this time we use what's called the horizontal line test. And it says if no horizontal line intersects the graph of a function f more than once, then the inverse of f is itself a function. So in other words, if I have, let's say, a line, okay, horizontal lines would only cross through that once, and so then its inverse is a function. And so really quickly we said, let's say this is y equals 1/2 x plus 1. So its inverse is, we're multiplied by 2, y equals 2x minus 2. And that is a function because that is still a line. So it would be something like that. Okay. But if I have a parabola, is its inverse a function? No. Horizontal line goes through it twice, and actually the inverse look like that. Okay. So consider the function f of x equals 2x squared minus 4 and determine whether the inverse of f is a function and then find the inverse. So is the inverse a function is the first question. So this is a parabola. Which way does it open? It opens up because your a value is positive. So if this is a parabola, does it pass the horizontal line test? It does not. And so determine whether the inverse is a function. So we know from the start that the inverse is not a function. And it does ask us to find the inverse anyway. So we're going to have x equals 2y squared minus 4. And remember then that we are solving for y. So we're going to add 4. X plus 4 equals 2y squared. You need to divide by 2. So y squared equals, and you could just leave it x plus 4 over 2, or you could write it as 1/2 x plus 2, either way. And then though, to get rid of that square, we're going to have to square root. And so however you want to leave it, there is the inverse, which is going to get us ready for the next section, which is going to be graphing square root functions. Alright, 2 more word problems to end the section. The volume of a sphere is given by v equals 4/3 pi r cubed, where v is the volume and r is the radius. Write the inverse function that gives the radius as a function of the volume. So that's telling you solve for the radius. So to do that, we write down the problem. How do we get r by itself? Well, I would start out by multiplying the whole thing by 3/4. So you're going to get 3/4 v equals pi r cubed, because the 3/4 is going to cancel with the 4/3 when you multiply it by 4/3. And then we're going to divide by pi. And that puts pi on the bottom, so you're going to have r cubed equals, I would write it 3v over 4 pi, because it goes on the bottom. And then finally, cube rooting both sides to get rid of that cube root. So we're going to have the cube root of 3v over 4 pi. So there is the inverse function. And then it says, determine the radius of a volleyball given that the volume is 293 cubic inches. So all we need to do is come back in and put in the cube root of 3 times 293 divided by 4 pi. I will caution you that when you put this in your calculator, if you do it all at once, you need to put parentheses around your 4 pi. So the cube root of 3 times 293 divided by 4 pi. Make sure you can get the correct answer out of your calculator. I get 4.12, and this is going to be in inches. And one last example. In fact, why don't you go ahead and pause the video and see if you can complete this. Alright, and for the inverse model that gives the radius as a function of the volume, I got r equals the square root of v over 10 pi. And when you put in 1050 for the volume, make sure you put parentheses around your 10 pi on the bottom, and you get 5.78 feet. Alright, that's what I have for you for 7-4. Let me know if you have any questions, and I will see you in class next time.